Yes, sir.
So we were doing angular speed. So we are starting with angular speed. Now, angular speed, if we consider like hands of our clock, right? We see that the when the hand of the clock is moving, if I consider minute hand, when it will complete one revolution, right? It will be rotated by which angle? It will be rotated by 360 degrees, right? Or we can say it will
Yes,
be
sir.
rotated by 2 pi radians. And how much time it will take to cover 360 degree or 2 pi radians? If I consider minute hand, so it will take 60 minutes,
Yes, sir.
right? Or we can say it will take 3600 seconds, right? So angular velocity is defined as key by what angle it has rotated in a given time, right? So angular velocity is defined as the ratio of angular displacement and time taken. Means per unit time, what angle is covered. As we define in linear speed ki per unit time, how much meter distance is covered. So in angular speed, we define ki in per unit time, how much angle is covered, right? It is denoted by omega, and angular displacement we can denote it by delta theta, time taken by delta t. So omega is equal delta theta by delta t we can denote, right? Now if I consider complete revolution, if I consider complete revolution. So in complete revolution, what will be delta theta? Delta theta will be 2 pi. And what will be time taken?
Yes,
Time taken to complete one revolution is defined as time period T, capital T, right?
yes.
So omega will become 2 pi divided by capital T. So this is one of the relation that we will use in our questions. Omega is equal to 2 pi over capital T, right? And what is 1 by T?
Yes.
1 by T is equal
Frequency.
F, frequency.
Frequency. Yeah.
The omega can be written as 2 pi F also. Now, solve question number 6 from your book.
Yes. And sir, since here we're writing speed here because they said angular speed.
Yeah.
But why don't we write velocity? Because
You,
angular speed means they're talking about direction also.
no, no, you can write velocity also. Angular velocity and angular speed one and the same thing.
Okay.
Yes, you can
But
write.
isn't the direction changing though?
No, see, direction is changing. Direction is
Yeah.
changing, but angular velocity, why we don't write, we write angular speed here. Because here we are talking about angle covered. Let's say particle is moving clockwise, anti-clockwise. Started from this
Yeah.
point, reach this point, it has covered 60 degree. And in second case, you
Yes.
consider it is moving anti-clockwise. Again, we are interested in the angle covered, that is 60 degree only. So angular displacement in both cases is 60 degree. That is why whether you write angular speed and angular velocity, one and the same thing.
So it wouldn't matter.
It won't matter.
Okay.
Yeah. So question number 6.
Yes. So, is the sixth A answer 72000?
What? 7?
72000.
Uh, A is 20. What was the see? Question is the clothes are held in cylindrical cylinder 1200 revolutions per minute. Per minute it is 1200. Per minute means 60 seconds. So in 1 second it will be 1200 by 60.
Yeah.
That is 20. And frequency is number of revolutions per second. So it will be 20 only.
Yes, sir.
Fine. And second part, you have to determine the angular speed. And angular speed, we have written here 2 pi f. So it will be 2 into pi into 20. So it will become like 6 to 12 and 5, 6, I guess. What will be the answer? You can check.
So, sir, this is already frequency because it's divided by time.
Yeah.
Hmm.
So what will be the final answer? You can check here. 40 pi, right?
Yes, sir, 45.
Now next we have relation between the angular speed and normal linear velocity. Now we will do relation between linear speed and angular speed. So if I consider minute hand only or second hand, let's say this is a clock and this is second hand of a clock. Now, if I consider different positions on this, let's say this is particle A, this is particle B, and this is particle C. And this is covering, so we know that if this is a second hand, so after 1 minute, right? So after 60 seconds, it will again reach the same point, right? So if I ask you after 60 seconds, what is the angle covered by ABC? Each ABC, what is the angle covered?
2 pi.
2 pi.
Yeah.
And is the time taken by all these three particles same or different to cover these 2 pi?
Um, I thought it will be the same, but it's not. That's what the textbook
It will
says.
be same only. If it is not same, this means the one particle is lagging behind, one particle is moving ahead. This means this
Oh
is
no, it
not
will
a
be the
straight
same.
line because one pointer is moving, so it is same only. Means both will all will take same time, that is 60 seconds only.
Yes, sir.
Same angle cover, same time taken. So this means ki all the particles have same angular velocity
Yes, sir.
because angular velocity is 2 pi over capital T or displacement by angular displacement time taken. So same angular velocity for ABC. But in these 60 seconds, if I talk about the distance covered, so particle A started from this point and it has covered this much circle. Particle B has covered this circle and C was moving in this circle. Now, if I ask you about the distance covered by these particles, is the distance covered by this particle same? Linear distance?
No, very
No.
much.
Because particle A has moved in small circle, circle of this radius only. Whereas particle B has moved in this circle. The radius of the circle made by particle B is more than that of A, and C has moved in even a larger circle, right? So, and whenever circle is given, the distance is equal to circumference only.
Yes, sir.
So this means particle C has covered the largest distance, then particle B, and smallest distance covered is by particle A, right? Now, but time taken is same or different? Time taken is same.
Same, sir.
Okay. Now, how is it possible that time taken is same, but one has covered more distance, another has covered less distance? We know that speed is equal to distance by time, right? If we keep time as a same, when time is same, this means the particle which is covering more distance in the same time, that particle is moving fastest or slowest
When it's covering more distance.
in the
Yeah.
same side. Particle
Yeah.
is covering more distance in the same time. This means the particle is moving fastest than the other
Yes, sir.
particle which is covering less distance. So now here we can see that the linear velocity is different. Linear velocities of particle A, B, C are different, right? On what factor the linear velocity is depending?
Distance.
Distance. Distance means we can say the radius. We can say radius also. Let's say this is the radius R1.
Yeah.
For the it is radius R2, and then there is one more particle. This is radius R3. So this mean linear velocity is dependent on, directly proportional to R. It is dependent on R radius. Any other factor which you think that linear velocity of these particles will depend?
No, sir.
If I consider minute hand instead of second hand, then
Time will change.
it will change. Or when we will consider minute hand, what will happen to the angular velocity?
It'll be slower.
Angular velocity will be different simply. It will change.
Yes, sir.
And when angular
Yeah.
velocity will change, so linear velocity will also change. So linear velocity depends on two factors. One of the factor is radius of the circular path, and second factor is the angular speed, right? So from here we can conclude that V and R are related by this relation. V is equal to omega R. So means linear speed is equal angular speed multiplied by radius of the circular path, right? Here we consider
Sir, but
example. Yes.
sir, doesn't here the linear, you said angular speed, it can be speed or velocity because it doesn't matter. It matters about the angle covered in per second, like
Yes.
in any direction.
Yes.
But isn't linear speed like going in one direction? So that's why, how will we say it's velocity?
No,
No,
no.
it's going in different directions.
Linear speed you're talking. Why we are writing speed, not velocity, you're saying?
Yeah. I'm confused with that, sir.
No, no. See, when we talk about velocity, it defines direction only, na? Here we just simple
Yes, sir.
mention clockwise or anti-clockwise particle is moving. So you can write linear
Yes,
speed,
sir.
right?
Okay.
In vector form, if you have to see, it is not in our syllabus, but Basically, this is all represented in a vector form also. Linear speed we are writing because we are writing for magnitude only. But otherwise, it is represented in
Okay,
vector
okay,
form also. But vector form is not in our syllabus,
okay.
right? So here we are writing for the magnitudes only, because if we have to write in vector form, we need to define the vector product. And vector
So
product,
even for linear,
what?
no, so you can continue. You can continue. I'll ask after.
Ah, vector product, when we define, if you know vector product, only then we can define linear velocity. Instead of linear speed, I will write linear velocity. But since we don't have vector products in our syllabus, so we are not referring to the linear velocity here. We are writing for linear speed only, that is magnitude.
Okay.
Now you can ask if you have any other query.
So, sir, even if you use velocity or speed, we're only talking about the magnitude for
Yeah,
angular speed and this.
yes.
Okay. Okay.
So now, next, just 1 minute. Now we can solve one question related to this. Question number 7 from your book. Uh, the angular speed of the second hand of a clock is 0.105 radian per second. So angular speed means omega is given 0.105 radian per second, and length of the hand is given. Length of the hand is given, that will act as a radius only for us. So that is 1.8
Yes.
centimeter. 1.8 into 10 to power minus 2 meter. Calculate the speed of tip. V you have to calculate. V is equal to omega r. So 0.105 multiply by 1.8 multiply by 10 to power minus 2. Right? So you can do this calculation and you can find. Solve question number 8 from your book.
Yes. So, 8A is 6 rad per second.
No. How do you find angular speed?
This is 90 degrees, right, sir?
90-degree means you have to you are writing radians per second. To convert 90 degrees to
Or
radians.
radian. Um, 1 by 30 pi.
Yeah. What are you getting? 1
1
by
by
30?
30%.
You have to write in
Yeah,
decimals. You can't write in fraction.
decimals. Okay. 0.1 105
Correct.
right per second.
Correct. Solve B problem.
So B part is 5.24 meters per second.
5.24 correct. Right? This is how we can solve this question. Now, we'll discuss about centripetal force. Now we will discuss about centripetal force. Whenever a particle is moving in a circular motion, let's say there is a particle moving with constant speed in the circular motion, and circular path of radius r, particle is moving anti-clockwise with linear speed v. Now, when particle is moving with speed v, we say it is constant speed. But what about the direction? If I consider these 4 points A, B, C, and D, and at this point, if I have to tell the direction of the motion, if it is moving anti-clockwise, so at A direction of motion, how can we find whenever curve is given? We draw tangent at that point. So if I draw tangent at this point, so this will be the direction of motion at A. At B, this will be the direction of motion. At C, this will be the direction of motion. At D, this will be the direction of motion. And we know that direction of motion and direction of velocity is always same. So here we can see that any object particle is moving with constant speed, its direction is continuously changing. Its direction is continuously changing. And how do we define velocity? We define velocity as speed with direction. Means even if speed is changing or direction is changing or both are changing, we can say that the object's velocity is changing. So in this case, direction is continuously changing. This means velocity of the object is continuously changing. And change in velocity per unit time is acceleration. So change in velocity means object is accelerating. Object is accelerating, right? So what we can see here in this circular motion, the speed is constant, but direction is changing due to change in direction. Velocity is changing, and the we can say that the object is accelerated. So this type of motion is known as uniformly accelerated circular motion. The uniformly accelerated means uniform here means constant speed. Accelerated means it is acceleration. Means its velocity is changing. Now in IGCSE, if you have done laws of motion, so Newton's second law states that F is equal to ma. In AS level also we have done this.
Yes, sir.
Or what does Newton's first law states? This is Newton's second law statement. From here also, if acceleration is there, so there must be a force acting on the object. And first law also states that if there is change in velocity, this means a force is acting, right? So what does that mean? If a particle is in circular motion, a force is always acting. A net force is always acting on the particle. And the direction of that net force acting on the particle is towards the center. Towards the center and along the radius. So if this particle is moving in a circular motion, at this point particle want to move straight, but a force will act toward its center, towards the center along the radius to bring it back in the circular motion. From here, particle will try to move tangentially, but that force will again act and it will bring the particle to the radius. Now, here from here, when particle will try to move, force will again bring that particle toward the center. So this force acting toward the center, force acting towards the center and along the radius is called centripetal force. From name only, it is clear that centripetal means it is acting along the center.
So I have one question.
Yes,
So you mentioned it is uniformly accelerated circular motion. If
yes.
it's uniform, it's you said it's constant, but there's change in velocity. That means that the acceleration value same or is it changing?
No, no, that acceleration will depend on the radius. It will be same. Acceleration here.
But the velocity is changing though.
No, no, velocity changing, direction is changing, magnitude is remaining same.
Okay, but uh, so
So the
there's a constant change. The change is constant, but
direction due to change in let's say from if I consider this point A and this point B,
yes, sir.
particle moving with velocity v in this direction. At here, this is moving in this direction with velocity minus v. So change will be 2v or minus 2v.
Okay,
Change magnitude was same, but change in velocity is there. It will become 2v or minus 2v. This change per unit
but
time.
yes, sir. Yeah,
Hmm.
but it's negative. Won't that mean the acceleration direction is changing?
No, no, no. This I have considered. Na, I can write, you can write 2v also, or you can write minus 2v also. Change means, see, you consider this. Let's say this is a circular path. This is point A, this is point B. If I consider at point A the direction of the velocity, so this will be the direction of velocity. Let's say this is V1,
Yes.
and at point this will be V2. Now, if I draw vector triangle, so this will be the vector triangle for this,
Yes, sir.
right? So it will act toward this. So this will be the resultant, means change, that is delta V, right? So it will be V2 minus V1, that is change. So this change will act toward the center always. If I consider this point B and this point as C, again here when you will consider this and you will draw this, you will get it along the center. Always when you will find the change, so it will be acting toward the center only. That change in vector.
So the change is constant. A change is constant.
Change is constant because that acceleration will depend on the velocity with which particle is moving and it will depend on the radius of the path. So since it is moving with
Yes,
constant
sir.
velocity and path is radius is also same, so acceleration will always be same.
Okay. And so you're saying why? So radius here, the diagram which you drew before,
Yeah.
you pointed an arrow mark from that head of the arrow, but isn't that's not the radius length though, right?
This is just
Because the
representation ki force is acting toward the center. Radius is
okay,
this only because circular path is this is the circular path, na?
yeah, yeah,
So if this is the circular path, this is the radius and radius will remain same. So this is just
Okay.
representation.
If
It will
radius
act.
changes,
Radius will remain same because circular path is same.
yeah.
It is just I have drawn this arrow
Yes.
to represent it. It will move along the radius and towards the radius. How it is
Okay.
accelerated to show this.
Okay, sir.
All right.
Yes.
Now, if we consider now if we consider different examples of circular motion, right? Right. If I consider first case, he a rubber bung on the end of a string. Let's say this is a string on the string one and this is a rubber band. Now, when you will whirl it in a circular path, right? Have you ever done this?
Yes, sir.
So if you have done this now, so you might have experienced key whenever you are doing this. So the string that you are holding, there will be some tension force on that string while doing this. You will
Yeah.
always feel whenever you are whirling it in a circular path, na, so there will be a tension force acting on the string, and that force you can feel if you are doing this. Now, what is the role of that force? See, initially, let's say you are holding this in this direction, right? Initially, you will give a jerk to this stone or any object that you have tied with the string tangentially. Can you imagine this? Initially, when you will start the object to rotate it in a circular path, initial jerk that you will give, that will be tangentially over, right? But initially you have given tangentially, but as soon as tension will start acting, to what will happen? Particle will try to move in a straight direction, but the tension in this string will bring it toward the center, right? Now from here, particle will try to move in a straight path, but tension will bring it along toward the center. From here, when particle will try to move in this direction, it will bring it toward the center, and it will continue to move in a circular path. So, what is the role of tension here? Is tension is helping to maintain circular motion, right? So, what we can say, and if any object is in circular motion, what force is acting on that particle? What is the name of that force? Centripetal
Centripetal.
force. So, in this case, how many forces can you see if we neglect weight of the stone? Only one force you can see,
One.
tension.
Yeah. Yeah.
So this
Yes.
means that tension is acting as a centripetal force.
Yes.
Or you can say the tension provides necessary centripetal force. Tension will provide necessary centripetal force. Right? So means whenever there is a circular motion, when we are talking about centripetal force, so there must be a force that will act as a centripetal force. And what is that force? That force is always net force. Centripetal force is net force acting towards center. This is most important point that I have written ki net force, because sometimes when we solve question, we have to consider this fact that we have to write the net force acting towards the center. Fine.
So the total force is a centripetal force acting
Huh.
here.
Total force, yeah. Net force acting toward the center is the centripetal force.
Okay.
right? Now, mm, my question is, what if string suddenly breaks? What if string suddenly breaks? What will happen? Now, if string will suddenly break, so what will happen? At any point, if I ask you about the direction of motion, so the direction of motion at any point is tangential, right? So if string will suddenly break, what will happen? There will be no tension. There will be no tension in this string, and the particle will, or object will fly off at a tangent to the circle. At a tangent to the circle. Is it fine?
Yes.
Anything you want to ask?
So, sir, so tension is the force that is causing it to be in a circular motion, and that's called centripetal force.
Yeah.
Okay.
If no tension,
Yes.
no
Let me just.
centripetal force, and it will not move in a circular path.
Yes, sir.
Right?
Let me just write the last point. Let me
Uh,
just write the question.
you can do.
Yes.
Now, if we consider motion of Earth, right, or if we consider any planetary motion, right, the Earth orbiting the Sun. When Earth is orbiting the Sun, let's say this is Sun, and around the Sun in a particular orbit, Earth is orbiting. Now, if it Earth is in circular motion or orbiting in nearly circular path around the Sun, so this means कि a centripetal force is acting. Now, if I consider system of Earth and Sun, how many forces are acting?
System and sun.
Huh. If I consider Sun and Earth, how many forces are acting? We know that only gravitational force is acting.
Centripetal. Yeah.
See, there must be a force that will act as a centripetal force, right? We will consider
Yes,
different
sir.
forces. Their net force will act as centripetal. So, if we consider Earth and Sun, gravitational force is acting. So, in this case, gravitational force provides necessary centripetal force. What does that mean? This means at any point, if I take the direction, Earth will try to move tangentially, but Sun's gravitational force will pull it back toward the center. It will try to move tangentially. Gravitational force will bring it toward the center. This is how it maintains its circular path around the Sun. And if the gravitational force will disappear, If the gravitational force disappears, then what will happen? Earth
It'll
would, yes, what will happen to the Earth?
it would it won't revolve around the sun.
Uh, it would travel off in a straight line.
Yes.
It would travel off in a straight line because it's at any point if we consider so it is moving tangentially only. Right. So if we consider like a car going around a bend on a flat rough road, right? Car is going around on a bend on a rough road. What do you think? What will provide the centripetal force?
Um, Friction.
Friction between the
Tire and the road.
tires and the wheel of and the road. And if I consider example of weight on the end of a swinging pendulum, yes. Again,
Um,
tension in the string.
so tension in this thing. That's what I thought. Tension.
Mm.
Tension.
So there is a question number 11 in your book. A car is traveling along a flat road in winter. The car approaches a patch of ice on a bend. Explain why the car cannot go around the perfectly smooth icy bend and suggest what might happen if the driver tries turning the steering wheel when the car is on the ice. Now only we have discussed that when car is taking a turn on a bend, friction provides necessary centripetal force. Friction provides centripetal force. Now, if it is an icy road, so what does that mean? There will be negligible friction or very less friction, right?
Yes.
If friction will be very less, so what will happen? Means there will be no centripetal force, right? If there is no frictional force, means what? And friction force is providing centripetal force. So if there is no centripetal force, so the car will not undergo circular motion, right? And what if driver tries to turn the steering wheel? Now again consider the case when there is no centripetal force. Here we have discussed now when there will be no centripetal force, the earth would travel off in a straight line. This we have discussed. Similar in this case, when driver will try to take a turn or try to turn the steering wheel and there is no frictional force, so car will continue in a straight line, right? Car continue in a straight line. Is it fine?
So want it like skid though. Want it like
Huh,
be.
it
How will
see
it travel?
this example we can consider. This is a bend, let's say. Wait. This is a straight road, and after a straight road, there is a bend, right? Now there is ice. It is traveling in a straight line. Now, it driver will try to take a turn, but it will not take a turn. It will move straight, and when it will move straight, so it is a skid only. This is what we call it will skid, and it will hit somewhere,
Okay. Yeah.
right?
So, sir, if friction is acting, that means friction is acting towards the center. From the tire and between the ground, it's acting, that is acting towards the center.
It is acting toward the center.
Okay.
This part I will discuss in detail also, ki how it is acting toward the center. Direction of the friction we
Yes.
will discuss. Right now, is it clear till this? Anything you want to ask?
Yes, sir. No, sir.
Okay. Now, vector diagrams we will consider. So, vector diagram means I have discussed already, but again I am repeating. So, this is a circular. Uh, Wait, let me. This is a circular path, and if I consider 2 points, let's say this is point A and this is point B. Now, on these 2 points, if I have to write the direction of motion, if I write from this point, so this will be the direction of motion. And if I consider this point, so this will be the direction of motion. So let's say this is VA and this is VB, velocity that particular. Now, if you remember from the vectors, if we can draw a parallel vector, like if I draw any line parallel to this and of same length, so this will also represent vector A. That is VA it will represent. Do you remember this?
Yes,
Parallel.
yes.
And similarly, if I draw parallel to this, like if I draw this, I can draw. So this is representing VB, right? And if I have to find the change in velocity, so earlier it was VA, now it is VB. So change in velocity is taking from VA to VB. VA to VB is the change in velocity, that is delta V. Now this triangle is given, vector triangle is given, and if I have to find the what will be the resultant here acting, we can write this equation that VA plus delta V is equal VB. Can we write this?
Um, yes, sir.
So delta V will be equal to VB minus VA, right? So here delta V will be change in velocity. So this is change in velocity, right? And with this, if I consider this only, this change in velocity, if I consider, if I move, shift it nearly and this side, if you will shift, so you will find that it will be acting toward the center. This change in velocity will be acting toward the center, right?
Yes.
So, and change in velocity is acting toward the center. We know that the direction of change in velocity and acceleration is same, right?
Yeah.
So, the acceleration of the object is same. The direction of acceleration of the object is same as the change in velocity, right? That is towards the center. Now, uh, if we consider the change in velocity, do you remember? Do you know the relationship between radius and tangent? If this is a
It's
circle,
90 degrees.
90 degree, radius and tangent are at 90 degree. So here we can see that velocity is acting tangentially. Velocity is acting along
Yes, sir.
tangent, and change in velocity is acting along. Change in velocity is
90 degrees.
along the radius,
90 degrees.
right? And tangent and radius are at 90 degree. What does that mean? Velocity and change in velocity are 90 degree. So what does that mean? Velocity and acceleration are at 90 degree. velocity and acceleration are at 90 degree. Which acceleration here we are talking about? Here we are talking about
Centripetal.
centripetal acceleration, right? So the change in velocity of centripetal acceleration will act at right angle to the velocity and it will be directed towards the center. And as per Newton's second law of motion, F is equal to ma, right? If F is equal to ma, what does that mean? This means the direction of force and acceleration is also same. Direction of force and acceleration is same. So if acceleration is acting toward the center, force will also act toward the center. And if acceleration is acting at 90 degree to the velocity, so force will also act at 90 degree, acting at right angle to the velocity. Here again, we are talking about centripetal force. And if you remember, I have discussed that the direction of velocity and direction of displacement is same, right? So centripetal force is acting at right angle to the velocity or displacement. Is it fine?
To the displace.
Yes.
So to the displacement, what do you mean by that?
Key, like if particle is moving in a circular path, if I ask what is the direction of displacement at this point A, so displacement is tangentially,
Oh yeah,
so
yeah, yeah.
velocity is also tangentially. So force is acting at right angle to the displacement.
Yeah, yeah.
Fine. So